Welcome back. This is Nick Agriam. I am discussing in this video factoring polynomials, sum and difference of two cubes. I will write it here. Sum and difference of two cubes. But before I'm going to do the factoring, I'll give you the general pattern. Then we will multiply this one, x plus y multiplied by x squared minus xy plus y squared. By multiplying that, we have x raised to 3. We have negative x squared y, and then we have xy squared for the last term. Now we have positive x squared. We have positive x squared y, and then we have negative xy squared, and negative y raised to 3. As you can see, this is 0, and this is also 0. The remaining product is x raised to 3 minus y raised to 3. And that is also the same when you multiply, x minus y instead. You will get, do that, and then you will get x cubed plus, I think I did that very terrible wrong there. That is not negative, it's positive. And this one is negative and negative. You will get, instead of positive, then you will get negative instead. What I am trying to say is that if I have a product of two cubes, the sum of two cubes, that is a product of this one, x plus y multiplied by x squared minus xy plus y squared. If I have the difference of two cubes, that is the product of these factors, xy plus y squared. As you can see, if I have for the binomial, this one is the binomial, if I have positive, then the second term is negative. If the binomial is negative or difference, then I have all of the trinomial is positive. Let's see if we can apply that in other sum and difference of two cubes. For example, you have 27 a raised to 3 minus 64 b raised to 3. Then you will see that 27 is 3 raised to 3, 64 is 4 raised to 3. Then we have the first the cube root, we have 3a minus 4b. And then the trinomial will be 3a in square. We have 3a. I will put this one. Maybe I will put a bracket instead. 3a. Because it's negative, so we have positive here. The product of the first and the second term. And the square of the last term, 4b squared. Simplify, we have 3a minus 4b, and we have 9a squared plus 12ab plus 16b squared. It's a pity because I cannot use some of the examples in your book. I cannot find anything, but I will look again and I will come back later. Yeah, I could find some. Let's see. This one. This is our example number 1. Example number 2 is a raised to the power of 3, or a cubed, plus 125b cubed. A cube, you don't have any problem with that, but 125 is 5 raised to 3. So we have a plus 5b, and then the square of the first term, a squared. Because this is positive, then the second term will be negative, so we have a multiplied by 5b. And then the last term will be positive. We have 5b squared. Simplify, a plus 5b multiplied by a squared minus 5ab plus 25b squared. Example number 3, for example, you have 2x raised to 3 plus 16y raised to 3. As you can see, 2 is not a cube, 16 is not a cube, but there is a common factor between them, 8 and 2. So we'll put 2 outside the parentheses, then we have x raised to 3 plus 8y raised to 3, raised to the third power. Now, we are ready. So we have 2 multiplied by, we have the binomial first, x plus 2y. 8 is 2 times 2 times 2, that is 2 raised to the third power. And then the trinomial now, we have x squared minus, because it is positive between the binomials, x. I will erase that. X multiplied by 2y plus the last term, we have 2y squared. Okay, and then we have 2 multiplied by x plus 2y multiplied by x squared minus 2xy plus 4y squared. I will stop there. I hope you learned something in this sum and difference of two cubes. Just remember that I will just put you there now where I started. Just remember, the sum is always the sum of two cubes is always the product of a binomial and a trinomial, and the binomial is the sums x plus y, as you can see here, and the trinomial will be the first term is the quadrat of the square of the first term in the binomial minus, remember the minus there, or else it will be wrong. And then the product of the first and the second term, xy. The third term in the trinomial will be the square of the second term in the binomial. The same is true with this, with the difference of two cubes. The only difference is that all of the trinomial, all of the terms in the trinomial is always positive. Yes, and good luck for your review if you're reviewing for your exams. And the next that I'm going to discuss is factoring by grouping. I already introduced that in factoring polynomials, general trinomial, factoring general trinomials. I already introduced in a sort factoring by grouping, but we will see what we can find also in this topic, factoring by grouping. See you next time.